Good evening, ladies and gentlemen. We're Team 9 of the Mobile Maniacs, and we've been working with Wakemed Mobile Services for the past year. My name is Varun Ganesh.
I'm Ivana Ganassi.
And I'm Catherine Thompson.
So the main problem that our team discovered is that during emergency situations, it is often difficult to consistently and efficiently provide left ventricular assistance to STEMI patients.
STEMI is an acronym standing for ST segment elevated myocardial infarction, and it is one of the deadliest forms of cardiac arrest. During a STEMI event, a clot forms that completely occludes the coronary artery, leading to muscular atrophy of the left ventricle. Such atrophy can be deadly within minutes. Now, the main device used in left ventricular assistance is the intra-aortic balloon pump, which uses a balloon catheter to keep the coronary artery open until the patient can receive further treatment in the hospital. However, during our observations at Mobile Services, we noticed that the ambulance which carries the balloon pump must be completely reconfigured before the pump is installed. This reconfiguration and installation takes 20 minutes or more, which cuts into critical time for the STEMI patient and is frankly unacceptable.
So in order to provide left ventricular assistance more quickly to STEMI patients, we are redesigning this installation process by fabricating a new mounting bracket for the balloon pump device. This new bracket must be able to withstand a maximum load of 53 pounds while secured in the ambulance setting and during transport to sites of medical emergencies. So after designing our device, we were able to determine that the best material to use would be aluminum. The larger holes, which can be seen on the picture here, are where the device would mount onto the base of the ambulance. The hinge, located on the front, would rise up and prevent any backward and forward motion. Furthermore, the two guides located on the sides, along with the pins located on the back guide, would prevent any lateral movement.
So based on our initial testing, we were faced with the problem of determining the proper casters that would need to be used in order to safely transport the intra-aortic balloon pump as well as the bracket itself. We chose to use casters that can withstand forces up to 600 pounds, which is well beyond what we expect the bracket to experience during transportation. Furthermore, we incorporated two locking mechanisms to ensure that the bracket will not move while the emergency patient is being transported by ambulance. Here we can see the first mechanism, which is a brake. There's a lever on either caster, which, like the brakes in your car, prevents the wheels from turning. This is extremely important in terms of not allowing the balloon pump to move while the patient is receiving care in the ambulance. Our second mechanism is a hinge lock mechanism, or swivel lock, which incorporates a pin on either caster to prevent any rotational motion of the wheels during emergency transport. It's really easy to operate.
Moving forward from here, we are going to focus on developing the quick release mechanism that will further streamline the installation process of the balloon pump. Afterwards, we will move forward to creating our device, which will include purchasing milled aluminum, and then after the device is created, testing the device according to our production qualifications. At this time, we would like to thank our mentors at Wakemed Mobile Services, Mr. Mark Dunn, Mr. Ed Wilson, Mr. Vincent Miliano, and Mr. Randall Heath. And from NCSU Biomedical Engineering Department, we would like to thank Dr. Andrew DeMeo, James Diefendorfer, and Steve Callender.